Alright, welcome to Introduction to C Programming. Today we are going to cover conditional statements, specifically switch statements. So we already talked about if statements with else and else-if statements. So to recap, conditional statements allow a certain section of code to execute only when a specific condition has been met. If that condition has not been met, then the code is not going to execute. Occasionally, an algorithm will contain a series of decisions in which a variable or expression is tested separately for one of a set of values. So maybe we prompt the user to enter a value like a menu-driven application where we prompt them and say, here are your choices, A, B, C, or D. Which one would you like? And then they enter a character, and it's going to fall into one of those four characters. Now, it could possibly fall into a different category instead of just one of those four. We'll have to handle that case as well. But it could just fall into either A, B, C, or D, and we can use a switch statement to check equality. So note that a switch statement can only be used for testing equality. It cannot be used for testing a range. What that means is that we cannot test to see if a value is less than or greater than another value. We can only check to see if a value is equal to another value using switch statements. That's one of the biggest differences between switch statements and if statements. So the way that a switch statement works, it takes as a parameter the variable or expression on which you want to compare a set of values. So let's say that we have prompted the user to say enter a character, and then they type in the character and we store it into a variable called value. We would then take that variable named value, and that would be passed in as a parameter to our switch statement. As we're going through the switch statement, we're going to have multiple cases, and each case is going to represent an individual value. So we have case, and then we have the single quote, a single quote. That's going to check to see if the variable that we passed in, which was named value, is equal to the character a. And so on. We can have multiple cases inside of a switch statement. If any of the conditions match, the body of all of the rest of the conditions will execute as well. Note that this is by design, and I'll show you in a few slides here why that's the case. However, keep in mind that once one of the case statements is true, it does match, then we will continue executing the body of all of the subsequent case statements. That's an important thing to note about switch statements, so please take note of that. We also have a default case. The default case allows an action to occur if none of the conditions matches, which is similar to an else statement. Now keep in mind that the default statement is also going to execute if any of the previous conditions also is true. So if one of those is true, it's going to execute the body of all of the subsequent case statements, and that includes the default case statement. I'll show you, there's a way that we can get around that, but that is the behavior of a switch statement. Okay, so let's take a look here at some code. Up at the top, I have just a simple if-else statement. You see on line 1, I say if the grade is equal to the character capital A. So grade is a variable. In this case, most likely it is going to be a char, a character variable. And we're going to check to see if it is equal to the character capital A. If it is, we execute the body of that if statement. It's going to print out pass. That's on line 2. And then we close our curly brace. If that condition is true, we are not going to execute the else statement at all. We're only going to execute one or the other. If the grade is not the capital A, we're going to get into the else statement. We're going to print out failed on line 5. Now let's look at the corresponding switch statement. This behaves exactly the same as the if statement at the top. So you see what we're doing is we are switching on the grade variable. We still have the grade variable defined probably as a character somewhere above switch. It's gotten some value somehow. Maybe we prompted the user, maybe we assigned it somewhere. So it's got some value inside of that variable, and then we have our inside of our switch statement. We have the open curly brace, and that takes us into the body of the switch statement. On line 9, we have case A. And you see that the A is in capital, it's a capital letter. It's inside of the single quotes. It matches what we had on line 1. So it's case A followed by a colon. And then anything that follows that until the next case statement or the default statement or a closed curly brace is going to be the body of that case statement. There are no curly braces here. You just put the colon and then you just start typing lines of code after that. It's very important also that you indent properly here with switch statements. This is going to help for readability very much. So line 10, I'm going to print out passed, and then I have another keyword that we have in C, which is the break statement. So line 11, I have the keyword break followed by a semicolon. What that is going to do is that breaks you out of the current structure that you're in, the current construct that you're in. What that will do in this case, it's going to break us out of the switch statement. So as soon as we get to line 11 right here, we're going to break. We are not going to execute anything else from that line of code all the way down to the end of the switch statement. We're going to break out of it. This is how we're going to get around having if case A matches. So if the grade was a capital A, we would execute all of the bodies of all of the conditions that follow. That means if this break statement was not there, so this statement on line 11, if it was not there, we would have printed out passed and then followed it by printing out failed if the variable grade had the value capital A inside of it, which was probably not our desired behavior. There are times where that may be your desired behavior. I'll show you an example of that here in just a second. Okay. Now, if the grade comes in and the value of grade is something other than a capital A, let's say that it's capital B. We're going to come in, we're going to compare it to capital A on line 9. It's going to say, no, that's not true. We're going to go to the very next case statement, which in this case is the default statement. The default statement says, well, we match everything. Everything is true. So in that case, we would just print out failed. So the if statement that you see there, the if-else statements that are on line 1 through 6, work exactly the same way as the switch case statements that we have on lines 8 through 14. Okay, so here's the example. You notice here that I do not have any break statements. That's what I'm trying to show you here on this slide. So looking at this switch statement to try to figure out what is going on here. So we still have that grade variable that we're passing into the switch statement. So if the value of the variable that was passed in was a capital A, it's going to print out excellent, right? This is easy to figure out. If it's a capital B, it'll print out good, capital C, A, capital D, I guess, and capital F, failed. If it is any other value like a capital E, capital J, M, Z, any of the other characters, then it's not going to print out any of those because none of the cases will match. In this case, we do not have a default case. Just like with an if statement, we do not have to have a default. We don't have to have an else statement. So with switch statements, we don't have to have a default case. That means that if none of those values matches, then we're just going to skip it. It's going to check all of those cases, and then just jump out of the switch statement and not execute any of the bodies. However, since we do not have any break statements in here, let's start off with the D. If the grade actually was a capital D, it's going to print out I guess, and then we are not going to check any of the other cases. Instead, we are just going to assume that all of the other cases are true. So we're going to print out I guess, and then immediately after that, we're going to print out failed. So if a capital D was the grade, it's going to print out I guess followed by failed. If a capital C is the case, it's going to print out A, I guess, and failed. If it's a capital B, it's going to print good, A, I guess, and failed. And if the grade was a capital A, it's going to print out excellent, good, A, I guess, and failed. Again, this is by design. If this is not how you want it to work, you have to include break statements in the body of your cases. All you have to do, type break followed by a semicolon. This needs to be the last line of code inside of that case, because once you hit a break statement, you're not going to execute any other line of code inside of the body of that case statement. So you could put it right here between lines 3 and 4. You could put a break followed by a semicolon between lines 5 and 6, between lines 7 and 8, between lines 9 and 10, and you don't need one down here, but you could have put one between lines 11 and 12. Since that's the last case, you don't need to put a break statement down there though. If you put a break statement between lines 2 and 3, let's say, which is before the printf, you will have a compiler error saying that that printf line is an unreachable line of code. What that means is that if you hit the break statement, you're not going to execute any lines of code that follow that. So it's going to be an unreachable line of code. Your code will not compile. So make sure that if you have break statements, this is the last line of code inside the body of the case. Okay, so take a look here. I've added a few break statements in. Let's see if you can figure this out. If the grade is a capital B, what is going to be output? So we're going to get into our switch statement on line 1. We're going to check the case A on line 2, and that is not going to match. So we skip over it and we go to line 4, which is case B. That does match. We're going to print out good, and then we are going to break. We are going to break out of the switch statement. We are not going to execute anything else. We're not even going to check cases C, D, and F. We're just going to break out of the switch statement altogether. If the grade is equal to a capital D, we're going to check line 2 and say, is D equal to A? No. Then we go to line 4. Is D equal to B? No. We go to line 7. Is D equal to C? No. We go to line 9. Is D equal to D? Yes. We're going to execute line 10, which is printing out I guess, and then we will break. So then we will jump out of our switch statement altogether. If the grade is equal to F, we are going to check on line 2. Is F equal to A? No. We go to 4. Is F equal to B? No. We go to 7. Is F equal to C? No. We go to 9. Is F equal to D? No. We go to 12. Is F equal to F? Yes. And then we will print out failed. Let's take one other example here. Let's say that it's a J. We come into our switch statement. Line 2 says, is J equal to A? No. Line 4, J equal to B? No. Line 7, J equal to C? No. Line 9, J equal to D? No. Line 12, is J equal to F? No. Jump out of our switch statement, and none of the bodies will be executed. Now, let's take these other ones. Make sure that you really understand how break works and how switch statement with the case statements work. Let's say that we get a capital A. So we come into our switch statement, grade is equal to capital A. We check line 2. Is A equal to A? The answer is yes. We print out excellent. We will not check line 4. We will not check the next case. Instead, we are going to go to line 5. We're going to print out good, and then we will break. So if the grade was a capital A, we're going to print out excellent followed by good, and then we'll break out of our switch statement. If the grade entered is a C, we're going to check to see, is it A on line 2? It's going to say, no, C is not equal to A. We go to line 4. Is C equal to B? No. We go to line 7. Is C equal to C? Yes. We print out A. We don't check line 9 to see if C is equal to D because we say we've already come up with the value of true. So we go down to line 10 and we print out I guess also, and then we break out of our switch statement on line 11. So if a capital C was the grade entered, we're going to print out A followed by I guess. Now, you may be wondering, why in the world is this the behavior of a switch statement, and how can this actually be as designed? And here, let me show you why. We don't have a sense of ors or ands with switch statements. We have no way of saying case A and case B or something like that. That one wouldn't make sense anyways. We're trying to match equality. So we have no sense of an and statement because obviously if we're equal to one thing, we're not going to be equal to something else. And we can only switch on one variable, so we can't check the values of multiple variables inside of a switch statement unless we nest switch statements, which you are able to do. So we don't have a sense of any and operators. However, when the switch statement was designed, the creators decided that there was a way that we could get the behavior of an or statement. The way that we can get an or statement is from what you see here on the screen. So when the grade comes in on line 1, line 2 says, is it case capital A? If it is, it's true, and it's going to execute all of the bodies until it gets down to a break statement or it reaches the end of the switch statement. Well, in this case, if A was true, it's going to skip over line 3, 4, and 5, and it's going to print out passed. Now, and then it's going to break on line 7. Now, what if it wasn't a case of a capital A? Instead, it was a case of a capital B. So we come in on line 2, it says, is grade equal to capital A? No. It goes to line 3 and says, is grade equal to capital B? Yes. We skip over lines 4 and 5 and we print out passed. What kind of a behavior did we just come up with? This is an or behavior. So what we have is if the grade is a capital A, capital B, capital C, or capital D, we're going to print out passed and then we're going to break. If it's at capital F or anything else, we're going to print out failed. So what we've done here is we've gotten the behavior of an or without actually using the or operator, which were the double pipes or the single pipes, depending on if you were using the logical or, the double pipes, or the binary or, which was the single pipe inside of a condition. So we do have a way to have or, but we do not have a way to do and. Since we're solely checking equality on a single variable, it makes no sense for us to be able to do an and, because you will never have more than one condition true unless you're checking for the same value, in which case you wouldn't need to have more than one condition. So it makes no sense to have an and operator for switch statements, just the or operator. Okay, Switch versus if. So a lot of people say, well, if these both can do the same thing, when would we choose to use one over another? The answer is this is more of a personal preference. You can use either one of them. The compiler is going to compile them both down to assembly code that looks very, very similar. So the efficiency is not going to be any different if you use an if statement as opposed to using a switch statement. It's still going to be just as efficient. So it's a personal preference on which one that you want to do. My own personal preference, if I'm doing some kind of a menu-driven application where I'm prompting the user to say enter 1, 2, 3, or 4, or enter A, B, C, D, or something like that, I would probably use a switch statement for that. It's very easy to do that. And we haven't talked about functions, but chances are inside of the case statement I would just call a function based on whichever variable or whichever value the user typed in. You could do it with if statements also. I've seen it done either way. That's just my own personal preference. Obviously, if you're using a range of values and you need to compare something that's less than or greater than, not equal, something like that, chances are you're probably going to need to use an if statement because a switch statement doesn't work for ranges. In addition, switch statements only work for characters and integer values. You're not going to be able to use it with float values because of the precision of floating point values. We're not going to be able to match precision-wise if we're checking equality like that. You could do it with the if statement yourself. However, with a switch statement, we can only use int and chars as the value, the variable which is passed into a switch statement. So that's another limitation of it. The second bullet that I have there is an important one. Every switch statement can be written as an if statement. However, we cannot go the other way around. So if we have a switch statement, we can easily write an if statement for it. However, if we have an if statement, we might not be able to write a corresponding switch statement. This makes sense, obviously, if the if statement has ranges or ands, multiple variables being checked, we're not going to be able to write a corresponding switch statement. However, if you have an if statement and all it's doing is checking equality on a single variable, you would be able to write that one as a switch statement. So keep in mind that you might not be able to write, or that you will not be able to write all if statements as switch statements. However, you will be able to write some if statements as switch statements. On the other hand, you can always write a switch statement as a corresponding if statement. Okay, that's it for switch statements and if statements. We're going to write a program next, so go ahead and watch that video now.